Today we're going to learn about matter, what it is and what it isn't, and atoms and their structure. So what is matter? Matter is anything that has volume and mass. So let's start with volume. Volume is how much space an object takes up. So for example, a 2 liter of soda takes up 2 liters worth of space. A gallon of milk takes up a gallon's worth of space. Those are both volumes. Mass is how much matter an object has. It's kind of sort of similar to weight, but not exactly the same. So let me explain. Let's say you're an astronaut and you step onto a scale and it says you weigh 150 pounds. And then you immediately jump onto a rocket ship. That rocket ship travels at super fast speed and gets you to the moon in 10 minutes. And you step off onto the moon and you get onto the exact same scale. Is it going to read 150 pounds? Nope. Well, why? You've still got all of your body. You've got your arms and your legs. None of that has changed. But what has changed? Well, you're on the moon now. And gravity has changed. Does the moon have gravity? Yes. But does it have the same amount of gravity? Nope. It has way less. It has 1/6 the gravity. So basically, on the moon, you are being pushed down on the scale less. Gravity is pushing you down less. And so your weight would be 1/6 of the weight as on Earth, even though all of the stuff that makes up your body is still there. In a science lab, we're going to be using a balance to help us find mass. And so this guy right here is an electronic balance, and it will typically give us readings in grams. Okay, so that's matter. So you might be saying to yourself, well, isn't everything matter? Doesn't everything take up space and have mass? Most things do. Soccer balls, yes. Pencils, yes. That super awesome lizard playing video games on the carpet, yes. Even the air we breathe has mass and takes up space. However, light, heat, sound, ideas, thoughts, emotions, those things are not matter. So then, what's an atom then? An atom is the smallest building block of matter. So if we were to take this Lego house here and break it down into its individual parts, those individual bricks are like atoms. Okay. This is a little bit confusing though, because atoms are actually made of smaller particles. So we'll get into that now. Atom has a couple parts. In the center is called the nucleus, and there are 2 particles in the middle, protons and neutrons. Protons have a positive charge, neutrons are neutral, or they have no charge, and more on charges later. Then around the nucleus, in like a cloud or kind of buzzing around like bees, are electrons. They're really, really tiny, and they have a negative charge. So let's look at helium, like what fills party balloons. Here is a model of a helium atom. Look at our nucleus. We've got 2 positive protons, and we've got 2 neutral neutrons. And then going on the outside are 2 negative electrons. Now, electrons don't travel in these perfectly beautiful circles, right? More of a cloud or a hive of bees, but it's hard to draw a cloud, so people usually draw them in circles. So let's say we get a whole bunch of atoms together. What do they make? Well, if we were to get all of the same atom together, like if we were to get a huge pile of red Lego bricks, all the same ones, and we just build a house out of those, that would be an element. A real life example would be like a bar of gold, like all the gold bars you have at home in your vault of money. If you were to look at the atoms in that gold bar, they would all be gold atoms. That's the only thing in them. That's an element. Most things in the world, however, are not just made of one thing. They're made of different kinds of atoms, and that would be a compound. So a common example would be water, H2O, is made of hydrogen atoms and oxygen atoms. That Lego house we showed, that would be a compound. Look at all the different kind of building blocks used to make that house. That would be a compound, not an element. Going back to helium here, I told you that this is what it is, but how did I know that this is helium? How do I know there's 2 electrons and 2 protons and 2 neutrons? Is there a way to figure it out? Of course there's a way to figure it out. I'm so glad you asked. We're going to be using a tool that is going to be your best friend in chemistry. The tool is the periodic table of the elements. So let's take a closer look. Typically in the upper corner, sometimes it's left, sometimes it's right. It doesn't really matter which corner it is. There's the atomic number. And this number tells you the number of protons. And as it turns out, that's really important because the number of protons in an atom is what makes it that thing. So anything that has 6 protons, for example, must be carbon. And if you change the number of protons, all of a sudden if it has 7 protons, it's no longer carbon. Now it is nitrogen, just by changing a proton. If you had 7 protons, now you add another one, boom, now it's oxygen, okay? So the number of protons is a defining feature, and the atomic number is equal to the number of protons. Now, for right now, unless you're told otherwise, the number of protons is also equal to the number of electrons. Now, this is going to change, but for right now, they're the same. So carbon has 6 protons and 6 electrons. Okay? There'll be a symbol, 1 or 2 letter symbol in the periodic table. There's also a name there. And then down below it is the mass. It's actually an average mass because they're all the way the same. And this mass number can tell you the number of protons and neutrons of the nucleus. So protons plus neutrons equals mass, or mass minus protons equals neutrons. So if we look at this, the mass is 12.011. We'd run that to 12. So 12 minus 6 is 6. There'd be 6 neutrons. Or another way to think of it is 6 plus what is 12? 6 plus 6 is 12, so it must be 6 neutrons. All right, so back to that helium. Let's just double check. If we look, helium's atomic number in the upper left-hand corner is 2, which means 2 protons. And for right now, at least, that means 2 electrons. And if we look at that average atomic mass down below, it's 4.003, which we would round to 4. 4 minus 2 is 2, so helium has 2 neutrons. Great. Let's look at another one, boron, okay. If we look at this, it's got an atomic number of 5, which means there are 5 protons and 5 electrons. And if we look, yep, 5 positive protons, 5 negative electrons. Let's figure out the number of neutrons now. We're going to round that mass off from 10.811 to the nearest whole number, which would be 11. So 5 plus what is 11? 6. Another way to think of it, 11 minus 5 is 6. That's why we have 6 gray neutrons in the middle. So notice the numbers don't always match. Carbon was 666, but boron was 565. Okay? So sometimes an atom has a charge. So what does that mean? Well, protons have a positive charge, and neutrons have no charge, and electrons have a negative charge. So to figure out the charge, we're going to completely ignore neutrons because they don't have a charge. Okay, so let's look at this lithium atom here. There are 1, 2, 3 red protons. So it'd be 3 positive protons in the nucleus. And there are 1, 2, 3 negative electrons surrounding it. So it'd be 3 negative electrons. Positive 3 minus 3. 3 minus 3, 0. So this atom would have a charge of 0 because our protons and electrons are the same. Let's take a look at another one. Okay, so here we go. Looking at the nucleus, we have 1, 2, 3, 4 protons. All right, we're going to ignore the purple neutrons because they have no charge. And we have 1, 2, 3, 4 electrons. Positive 4 minus 4 cancels out to 0. So this, too, would have no charge. What kind of atom is this? Well, remember back, the number of protons determines what it is. So 4 protons, we would look on our periodic table and look what's number 4, and that'd be beryllium. So this is beryllium. Okay, now let's try a different one. Okay, 11 protons, 12 neutrons, and 10 electrons. Okay, so what element is this? Well, the number of protons is the determining factor. So I would look at my periodic table, look for number 11, and number 11 is in fact sodium. Okay, so this would be an atom of sodium. And what's the atom's charge? Remember, we're looking at protons and electrons. We're ignoring neutrons. So 11 positive protons and 10 negative electrons. 11 minus 10 is 1, positive 1. Oh, so it has 1 more proton than electron, which means it's going to have an overall charge of plus 1. Let's try a different one. An atom has 8 protons, 8 neutrons, and 10 electrons. Okay, what element is this atom? Well, what has an atomic number of 8? That would be oxygen. So this must be oxygen. And so what's the charge? We have 8 positive protons and 10 electrons. So 8 minus 10 is negative 2. Which means this atom's charge would be negative 2 because there's 2 more electrons than protons. And we're going to do a lot more practice with this in class. If you were wanting to look to see where any of this info is in the textbook, it's in Chapter 1, Sections 4.1, 4.2, and 4.3.